So the last thing that I want to talk about will be the resistance. There are a lot of kind of misconceptions out there as to what changing the resistance actually does. In this case, in this designation, we see that we have 120 ohm strain gauge. It's very common with the strain gauges that we offer here at Micromeasurements. 350 and 1,000 ohm are also common here, and we do have certain gauges that can go up to 5,000 ohms in resistance. The difference in resistance isn't really one of accuracy, but rather of current and heating going on. So basically what this means is that when you have a strain gauge that is effectively a resistor, it's a foil resistor, when you apply a voltage across this resistor, you're inducing a current, and the current being induced will it will be proportional to the voltage that you're applying it to. So depending on the current, so if you have a larger current, then if you have a larger voltage, that also means that you are inducing a larger current on your strain gauge. And the reason that this is important to kind of think about, even though it might sound a little basic, is that by inducing a current across your strain gauge, that area, that place where the current is being induced represents a source of heat. It represents a source of energy that's being placed on top of that strain gauge. And depending on the material that you install your strain gauge on, it can become difficult to basically dissipate the heat that's being induced across that gauge. And really this is the crux of the whole argument of using 120, 350, and 1,000 ohm gauges. They'll all come with their gauge factor. They'll all be able to give you the output that you want. But what you are interested in this case, is stability. How stable do you want your measurement to be? If you have a 120 ohm strain gauge, because of that smaller resistance, you will have, if you apply a certain voltage to a 120 ohm gauge and a certain voltage to a 350 ohm gauge, they can be the same voltage, but because of their different resistances, means that you will effectively end up with different magnitudes of current being induced. And so by having a 350 ohm strain gauge means that with the same voltage being induced, you run less heat now. You are creating less heat on the gauge, because even though you're applying the same voltage that was being applied to the 120 ohm gauge, because of this higher resistance of the strain gauge, you are now seeing a smaller current being induced, and thus less heat needing to be dissipated into the material. And a lot of times, depending on, especially if you're dealing with like metals, aluminum, steel, things like that, they might do the job well and be able to dissipate that heat, but once you start getting to things like plastics or materials that can't really dissipate the heat as well, at that point you start creating a potential source of problems for you, meaning that you'll lose stability on your signal. And so that's really the kind of the main difference in using 120 ohm versus 350 ohm versus 1,000 ohm. And whatever I just said for 350 versus 120 will also apply to 1,000 versus 350. Ideally, in a perfect world, you would want to be able to go as high as you want on the resistance of your gauge, because it can only really help you. Obviously, sometimes we can't always do that, because a lot of times we're dealing with certain instrumentation that can only support certain resistances, or certain resistances might be in stock, or certain patterns that we like to use might not come with that high resistance. But usually using a high resistance helps us by allowing us to be able to hit that strain gauge with a higher voltage without worrying about the heat needing to be dissipated. But because of this, because of the current that's being induced is now smaller, it also lends itself well to using like battery powered devices. So if your data acquisition or certain instrumentation that you're using that's applying the voltage to the strain gauge is battery powered, because by using a higher resistance means that you're using a smaller current, also means that you can get a longer life out of whatever instrument that you're using, since it's requiring a smaller voltage. And the thing too with this, choosing the right resistance and using a higher resistance means that you can also have a better signal to noise ratio. So one of the ways that we want to usually be able to maximize the signal output that we're receiving, it would be to simply increase the voltage. But like I said, by increasing the voltage, we're also increasing the current, increasing the heat, and by using a higher resistance, we can go to higher voltages without having to worry as much about the heat being induced at the site of the gauge and needing to be dissipated. So it also helps us in not only, and basically ensuring a more stable signal and making sure that we can end up with a stronger signal overall at our output.